In this video, we're going to talk about how to calculate the derivative of an arccotangent function, which is as follows. So the d by dx of an arccotangent x is equal to negative 1 over 1 plus x squared. Or a better way of looking at it is the derivative of arccotangent x is equal to negative 1 over 1 plus x squared dx. Or, in other words, the derivative of arccotangent box, okay, whatever is in this argument here, is equal to negative 1 over 1 plus this box squared times the derivative of this box. One thing you'll notice too is that the derivative of an arccotangent function is just the negative of the derivative of an arctan function. Okay, so it's the same expression, we're just adding a minus sign in front of it. So as an example, let's say we're given this function here, f of x is equal to arccotangent 1 minus x squared. To evaluate the derivative f of x, which we can also write in Leibniz notation, df of x by dx, we will go ahead and follow this format here. So we would write negative 1 over 1 plus this entire term squared. Okay, so we'll go 1 minus x squared squared. And then we're going to multiply this by the derivative of x squared. And we know that from our power rule, the derivative of x squared is equal to one thing we should keep in mind too is that we're actually not just doing the derivative of x squared. Okay, we're doing the derivative of this entire term here. So using a combination of the sum rule and the power rule, the derivative of 1 is just going to be 0, okay, minus the derivative of x squared, which is equal to 2x. So we can go ahead and further simplify this expression. So now this 0, we can just kind of ignore that, and then the two negatives cancel out, so we'll have a positive, but I'll write it this way just for demonstration purposes. So this will be the same thing as negative 2x divided by 1 plus this entire term squared. So what we can do is we can expand this this term here, and what that'll give us is 1 minus 2x squared plus 4x to the power of 4. And then we can go ahead and simplify this even more. So the two negatives in the numerator cancel out, so we have 2x over and then when we get rid of these brackets, we can add up the ones here. So we got 2 minus 2x squared plus x to the power of 4. Sorry, this shouldn't say 4x, my bad. I'm just going to correct this here. It should just be x to the power of 4. There we go. Okay, so now we can go ahead and further simplify it even more. Okay, now of course we could leave the answer in this form, but it's actually more conventional to write it this way. X to the power of 4 minus 2x squared plus 2. Okay, and that would be our answer right here. So let's do one more example here. So let's say we're given this function here. We're given the function h at t, h at t is equal to the arccotangent of cos e to the power of t. All right, so there's our function there, and we want to evaluate the derivative of it. What we would do is h prime at t, which we can also write as dh at t by dt, okay, in Leibniz notation, is equal to negative 1 over 1 plus this entire term here squared, so cos e to the t squared times the derivative of this term here. So times the derivative of a cos is a negative sign, so negative sign. And what we're going to be doing here is using our chain rule. Sine of e to the power of t times the derivative of e to the t, which is just e to the t. E to the t. Okay, so that's the first step there. Of course, we can leave the answer in this form here, but we can clean it up a little bit and simplify it. So what we'll notice up here is that these two negative signs here cancel out, and so we're left with a positive expression. So we'll write e to the power of t times sine e to the power of t divided by 1 plus cos squared e to the power of t. Okay, and just putting the squared right after the cos is another way of writing this term here. Okay, these two are the same thing. Okay, and there you have it. That's our answer. So that is how you evaluate the derivative of an arccotangent function.